on this. All right, so let's move this down just a little further. All right. Okay, so this is the class website. We go to the syllabus/schedule. Today is March the 12th, and we're talking about exceptions, file and IO, and regular expressions today. But I guess I promised you first we'd talk about the midterm, right? Still, anybody still want to see the midterm? Okay. All right, so let's do that. All right, so the true or false stuff. This should have been, you should have all had this in your memories, right? Quick sort is an example of a recursive sort. You should know that. The merge and the quick and merge sort is an example of a recursive sort. That's also true. And the merge sort we studied in class is stable, and the quick sort we studied in class uses a random number. Those are all true statements. The merge sort we studied in so you can't, I mean, I've never seen a merge sort that used a random number. Maybe someone could come up with one, I don't know. And the quick sort that we showed in class was not stable. And we talked about, you know, basically that was a byproduct of it being in place. And any questions on this? Good. All right. A student proposed a stable version of the quick sort routine. Instead of sorting in place, this student says this routine returns a sorted copy. Does it work? Why or why not? And so when I show you codes on quizzes and tests, right, I want to show you things that you haven't quite seen before, right? Something different, because the point is this class is not about memorization. Yes, memorization is a component, just like it is in most things. But if you don't know how to take the things that you're learning and apply them to new situations, then it's pointless. So that's the reason for this sort of question. All right. So what I did, the way this works, if you look at it, we have our usual, we have a bailout condition here, right? If the thing is too small, then we want to leave. And right off the bat, you're going to say, well, if I have a list of two things, it might not be sorted, right? So this is less than or equal to 2. You normally see less than 2 here, or less than or equal to 1, whichever. So this is a problem right away. So if I pass this a list of two things, it would just return it, and that's not right. The second thing is to observe right here is it's supposed to return a copy, a sorted copy. And this is not a copy. This is just a reference to the thing that was passed in. So that's two problems in that first line of code. So now what we do is we create 3 arrays, low, equal, and high. And the idea is we're going to sort the points into those buckets, right? I still have a cough. All right, so I'm going to go through the list of things. And if it's less than the pivot, I'm going to add it to the low. If it's greater, I'm going to put it in the high. And if it's equal, I'm going to add it to the equal. Seems easy enough, right? Now, I'm going to create a results array. And in the results array, I'm going to add all the low elements, all the equal elements, and all the high elements, and then return the result. So basically that should work, right? And that's going to be stable because nothing ever swaps, equal things never swap position, right? We have the low, the equal, the high, and they all stay exactly in their buckets in their order. So that should all be fine. So this quick sort routine is correct. Well, it's not, because we already said on the first line there were 2 errors. Even with bugs corrected, this quick sort is not stable. Well, it is stable. We just talked about that. The first line must be less than or equal to 1 instead of less than or equal to 2. Correct. There must be an equals sort eq, just as there is for high and low arrays. Well, no, because if it's eq, it's equal. It's already sorted. It's just the same value. So there's nothing to do there. The sorting of the low array must happen before the sorting of the high array. There's no requirement on the order, right? Nothing about that matters. The pivot val must come from rand next int list size instead of list dot size over 2. Oh, I failed to mention that. That's certainly true. The pivot val has to come from a random number. And it should be this first one here, not the second one with the over 2 arbitrarily thrown in. And the return at the top must contain a copy. Yes, that's true. The return at the end must return a copy. Well, it's already a copy, actually. We allocated a new array, so that's not true. An optimization would be to remove result and to append eq and high to the low and return low. That is also correct. If you just look at the code, you can see that there really isn't a need for creating a result and then adding low, equal, and high. I've already got an array called low with all the lows in it. So I could just say low, I could just get rid of this and I could say low.add and low.add and return low, and that would all work. Is there any question on that? I'm surprised that there is no question on that. I think some of you are asleep. Yes. What's your name? Julian. Yes. So if I give you a list of 2 things, for example, 5 and 3, 5 and 3 is not sorted, but yet I'm just returning it, right? The idea behind these sorts is when we have our bailout condition for the recursion, we want to return the list if it's 1 or 0 length because that's already sorted. Any other questions? Oh, and then there's the copy issue. So in the instructions, it says it's supposed to return a copy and it doesn't. It just returns a reference to the original thing. Any other questions? Okay. What is the output? So we have class hello, and this is a variant on the one that you saw in the practice tests. I just changed up the numbers and the ordering a little bit. And again, the way to follow these things is to follow them through logically. So you start with main, and main gets called with 3. I put a 3 here. Is n equals 6? No, that doesn't happen. So I print out the 3. So right now, right by this point, we have limited our answers to the things that start with 3, right? That has to be what comes next. All right, so sorry, I'm just sniffly. I mean, it's not only the cold, by the way. I have allergies, and when I have a cold, my allergies are worse, and so sniffles abound. Okay, so anyway, I print out the 3, and then I call it with a 4, okay? So is 4 equal to 6? No. Okay, then I'm going to print out the 4. Okay, so now I know that I have 3 and 4 have to be the beginning sequence. I've now got it down to 2. If I'm just guessing, I have a 50% chance now. So next I'm going to do a 5. And it's going to do the same thing. It's going to print the 5. So I'm going to have 3, 4, 5 has got to be there. 3, 4, 5 has got to be there. Now I'm going to do the 6. And the 6 is going to return bang. It's going to print the bang and return. So it's got to be that one. Right? That's the way you need to think these through. You have to start with the main method, and you have to go line by line. Any questions about that? All right. What is the output? And I have the same question, or is it? Right? So what's different between this one and the other one is the order of the recursive call and the print statement. So what's going to happen with this one is it's going to essentially print it in the reverse order, right? When I get all the way up to 6, it's going to have to get all the way up to 6 before it prints, which means the exclamation mark has to come first. And it's not going to print the actual 6 because it returns when n is equal to 6. It doesn't get down there. Well, I'm sorry. Let's just go line by line. I'm trying to rush things, and I'll probably make a mistake if I do. So I start with hello 3, right? And then I go up here with 3. Is 3 equal to 6? No. I call 3 equal 4. Okay. I call n equal 4. So is 4 equal to 6? No. Call again with 5. Is 5 equal to 6? No. Call again with 6. Is 6 equal to 6? Well, yes, it is. So print a bang and return. Okay, and now we're coming back to here. And the value is 5, right? So it should be bang 5, 4, 3. Make sense? All right. Group sum. I bet you love this one. So this is very similar to the problem that we saw in the preparation, except for this line is different. And this line was always the problem. It was the problem in the last one. It was it was different from the class example. In this case, rather than, so in the class example that we did before, we checked to see if the next value was divisible by 3, and if so, we couldn't use it. In this case, we're checking to see if the sum of the current value and the next value is divisible by 2, and if that's the case, then we can't use it. You see that? You know, I always love when you ask students, do you understand something? And they look at me like this. Like, I'm getting a mixed message there. Anyway, these looks of absolute horror, you know. Okay, so let's see about this one. So we want to make the sum of 3, 2, 4, 8, and 16. Can we make a 5 out of that? Well, the way to make a 5 out of that, the only way really, would be to add 3 and 2 together. Now, if I add 3 and 2 together, do I get an even number? No. So I can use that one. So that one should be true. Let's just see how we go. All right. And then the next one, I want to build a 6. So I have a 2 and a 4 that I need to add together to make that happen. Can I use that combination? No, because if I add 2 to 4, I get an even number, and so I can't use both the 2 and the 4. So that one's going to be false. The next thing I'm going to try to make is a 7. To make a 7, I need to use the 3 and the 4, and those aren't next to each other at all. So I don't have to worry about that special line of code. And yes, I can do that. So that's true. And then for D, I'm trying to make 12. And to make 12, I need to add 4 and 8. And 4 and 8, when I add them up, is going to be an even number, so I can't do it. So that's false. And then the last one is 13. And to make a 13, I need, what do I need to make a 13? I could do a 3, a 2, and an 8, right? That should be 13. And the 3 and the 2 are next to each other, but they don't add to an even number. So that's okay. And 8 isn't next to either of them, so that's okay. So that one's true. Make sense? Again, it's something similar to what you've seen, but it's different. It's just checking to see whether you can, adapt, which is what you need to be able to do. And this was also an adaptation. And I threw in a method call in here for those of you who never understood the difference between call by reference and call by value. Since this is passing by reference, the fact that there's a method here doesn't mean that the values can't change. They can. So let's take it line by line. Start at main. We create this Z array with 5, 4, 3, 2, 1. We call buzz Z. Buzz Z is going to take that same array. It's going to set I equal to 4, and that would be this value, right? And then it's going to say Z I minus minus plus plus. So that's going to decrement I, but it's going to remain 4 for the purpose of this expression. So I'm going to decrement the fourth thing. 0, 1, 2, 3. What am I doing wrong here? Oh no, it's going to increment the fourth thing. The fourth thing is going to be 2 because this is a plus plus here. And so I'm going to stay with this one, and I'm going to increment this to 2, but I is now going to be 3. And then I'm going to do the minus minus I. So that will decrement I to 2 before it uses it. And then it will add to the value that's there. So this will become a 2, and this will become a 4. And so I want 5, 4, 4, 2, 2. Right? Okay. This should have been easy. This is actually copied from an old exam. I don't think I need to go over that. Fill in the blanks. So I have a bubble sorter. I believe this is also copied from an old exam without modification. So, so basically line 1 is going to be done equal false. Line 2 is going to be done equal true. Line 3 is going to be array.length that we're going through. Line 4 is going to be array -1. Yeah, array -1 because I want to compare adjacent values and see if they're out of order. And 5 is going to be done equal true. Any questions? All right. If you studied the bubble sorter, you should have passed that with ease. And here was a selection sorter, but I changed it up a little bit. So I created a subroutine called find min. And the idea is I call find min on the remainder of the array from the position I'm at. And then I'm going to store that, and I'm going to do the swap in line here. So the way this is going to work is I'm going to say, if it's going to start out with I, if I'm going to get array get I is less than I min, then I'm going to update array min, right? And that would be blank 3, and blank 3 should assign I min equals I, right? So that's how I do the find minimum. I go through there and I start with a value for I min, and every time I find something lower, I update it. And then at the end, I return that I min here. Okay, so this is now the minimum of the remainder of the array. So I want to swap that with my current position. So I'm going to say temp I, and then I have a choice here. But what I'm going to do is I'm going to say temp I is going to be the array value at I min. And now the next thing I'm going to do is I'm going to set the value at I min. So I'm going to override this. So I'm going to say I min is going to be get I, right? And then at the end, I set I to temp, and that sorts the array with a selection sort. Any questions? Again, if you understand that conceptually what a selection sort is doing, the variation in the coding shouldn't have confused you. All right. What is the time complexity? This is more or less a memorization answer. Bubble sort is O(n) squared, selection sort is O(n) squared, merge sort is n log n, quick sort is n log n, linear search is n, and binary search is log n. And putting 2s in here and +1s and things like that is always wrong, as we've discussed. Any questions? All right. What is the output of the following code? Well, what's our procedure? We start with main and work our way through. So we're going to say int foo equals new int, and then we're going to have 1, 2. Then we're going to have runnable R. I think this might be a direct copy of an old exam question. I might have changed the constants. I can't remember. Anyway, it's 1 and 2. So I'm going to say runnable, and then I'm going to have this lambda expression here, which is syntactic sugar for an anonymous inner class. And inside that, I'm going to increment foo 0 ++, which I can do because of capturing rules. Okay, so if this method were to be called, it would increment this first index, but it isn't called yet. It's just the method is just created. The runnable class is just created. So now I'm going to say ++ foo 0 equal foo 1 minus minus. Is that true? Well, plus of foo 0 is going to evaluate to what? It's going to evaluate to 2, correct? And that's going to leave foo 0 with a value of 2. And foo 1 minus minus is going to evaluate to 2, but it's going to leave foo 1 at 1, right? So now we've got, does 2 equal 2? And that's correct. But the array at this point, after evaluating the if, is 2, 1. Now on the next line, I'm going to reassign this thing to decrement foo 1. And so when I call it, I should wind up with 2, 0. Any questions? Yes. To Julian, right? Yeah. Yeah, so we start out with the array being this, and then we create a runnable, but this doesn't actually get called yet, right? It's just in standby mode. Now I'm going to evaluate this expression. And this expression, because of the plus plus and the minus minus, is going to flip these two values. It's going to become 2, 1 at the end of this expression. But this is a prefix operator. So I do the increment first. So this evaluates to 2. But this is a postfix operator. So it evaluates, so the decrement happens after the return value is given. So this also evaluates to 2. And so this whole expression evaluates to true. Therefore, runnable gets reassigned with this new method, with this new class that has a run method that does a decrement of 1 on foo1. And since foo1 is currently 2, 1, when I run it, it becomes 2, 0. Are we good? This kind of question is fun, right? Because it really exercises your brain. Imagine now that I can take this stuff and throw exceptions into it, and make you follow exception chains. Wouldn't that be fun? I can just see the joy and feel it radiating. And this is identifying types. And I think, I'm not sure if it's a copy or not. It's very similar anyway. So system is a class name, is a static field name, printf is a method name, bar is a method name, math is a class name, and cos is a static method name. Any questions about that? Good. All right. So that's the old exam, the previous exam. So, and I think overall people did a little better than the class as a whole did a little better than I expected. I thought some of the new code, some of the different variations on the codes would throw you more than it did. And I'm pleased that it turned out as well as it did. I mean, obviously some students didn't do as well as others, but that's always true. All right, let's return to where we were. And what we were looking at was, let's go back to, we were going through that last slide. That was fun. All right. Thanks. All right. Exceptions, IO, and regex. And slideshow. And when I was we were on the last slide. And here we go. Readers and writers. That's what it was called. And let me just make a copy of that. Okay, so what we did in the last class was we went through this first part, and that was basically all we did. Next thing we're going to do is talk about file IO, because if your programs can't open, read, and write files, they're kind of useless. So, and so what you've been learning right now, right, is just sort of little math tricks and puzzles and so on, and you know, some algorithms, but you need to have file IO to really accomplish anything. So there's in the java.io package, there is a class called file. This is the abstraction of a file. And in this case, that my file is going to be called output.txt. Now, if I want to delete the file, I can call the delete method on file, and that will do the job for me. Likewise, if I say file.exists, that will return true if the file exists. Now, in this case, it shouldn't exist because I just deleted it. Now we're going to see, I think this is the first time we're seeing this. This is a new kind of try block. So we saw try catch in the last example, in the last class, and we had try with open curly brackets immediately following it. But this is a different kind of try. This is a try with an open parentheses, and inside the parentheses, I initialize an object. And if that object implements interface closable, which has a single method on it, void close, then this can work. And what will happen is Java will automatically close the file for you when you get to the end. It's kind of like I wrote try with an open curly, and I put this code inside that try block, and then I had a finally clause where I closed it. It's really kind of the same thing as that, just more syntactic sugar, as it were. All right, so what I'm going to do is I'm going to create something called a file writer. And a file writer is what it sounds like. It is a class that allows you to write information to files. And I can say fw.write, and I hand it a string, and it will write that file to disk. So I have Jane Doe 28, and then a new line. I can reset, or I can do it another way. I can say fw.write string.format %s %d %n, and that's John Doe 30, and that's going to have the generic line ending instead of the /n. And that writes a file with 2 lines in it, Jane Doe 28 and John Doe 30. Any questions? All right. Now I can read a file as well. And you can do that a couple of different ways, but there's a file reader object that you can create, and you can pass that to a scanner, because I know scanner is an old friend that's used heavily in 1350, and it's just a convenient class to use. And I can say, well, the scanner has another line, then print out the next line. So I can read the file line by line and print it. Make sense? Because this is a try block with parentheses, it will automatically close the file reader. It's important to always close your files when you're done using them. There's a number of different reasons for this. One of them is that the way operating systems work is they have a maximum number of open files usually. And it turns out that you can write a fairly generic program to crash a system by writing a program that opens as many files as it can, forks, and then the forking process opens as many files as it can, and it just keeps doing that. And usually the product of the number of open files you're allowed to have per process multiplied by the number of processes you're allowed to have is bigger than the number of open files that are allowed to be on the system. And so if you do that, you wind up crippling the system because nobody can open any files anymore. And if you do that, you are a bad person, unless it's your own machine. But it's a problem that you should be aware of, because I say it's a bad person, but you're a bad person if you do it. But it's always possible to do things like this accidentally, right? Okay. There's another reason, though, and we'll get to that in a minute. Another reason to keep them, to always close them. So here we're going to read the file, and we're going to, instead of going line by line, we're going to use the scanner's hasNext capability, and we're going to read 2 names and an integer with that scanner, and then we're going to print them out, first, last, age. And so what we're doing is printing it out and reformatting it, parsing the data and reformatting it, because scanner allows us to parse data in a very primitive way. All right, any questions? I can just keep flying along as long as there's no questions. I can cover all new material. Okay. So I told you that the try parentheses construct works with anything that's closable. And that means that you can make use of it with your own classes. In this case, I have the closable interface. And what do I have here? Anonymous inner class. So I have keyword new, class name, parentheses for the constructor, open curly. Public void close, because all methods in an interface are public. And then I'm just printing out the word close. So it says test of closable, and then it's going to print close after that. Make sense? Let's. Yes. I brought 2 drinks with me today because I know I'm coughing a lot. And all right, so this is the code we've written so far. So this was the stuff we talked about last class. This was reading the file and spitting it back line by line. And this was reformatting it. And then this is our test of closable, followed by the word close. Are we good? Does it all make sense? It's all, yes. Shoot, what's your name again? Drew.
So in the example we just saw, there was a scanner, but you didn't type, so how do you?
Well, so if you go back, if we go back and look, what we did, the scanner, the constructor to the scanner is taking a file reader object. All right. So that's telling the scanner that instead of reading from the standard in from the keyboard, it's going to read from a file that I've opened here. All right, so now I'm going to teach you a life-changing thing, right? Regular expressions. Regular expressions are wonderful, marvelous things that I use almost every day of my life. They are language independent for the most part. They're used in Python, Java, C++, any language you use practically. There is a regex library. And regex libraries are a more sophisticated way of parsing strings than what scanner gives you. By the way, scanner can also be opened with a string, in which case it will parse that string instead of the keyboard input. All right, so the way regexes work is they have this super cryptic notation that once you get used to it is fairly easy to construct. And it allows you to easily specify what it is you're looking for in a string. And there's this nice t-shirt that you can get with an XKCD comic where the guy is swooping in on a rope from the ceiling with and there's a computer there. It says, "Stand back, everyone. I know regular expressions." And I used to have that shirt, but it died. It lived its life. All right. So here's a couple of the symbols in regular expressions. So you can have a square bracket, and a square bracket is just like a group of possible characters that match. And if you put a dash between two characters, it means a range. So 0 to 9, so square bracket 0 to 9 will match all the characters 0 through 9. Now, I could also write that as square bracket 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, close square bracket. And that would do the same thing. But this is a little better, a little more convenient to write. And then this, but this whole thing with the square bracket 0 to 9 in there can also be abbreviated with \D for digit. There's another abbreviation where we take A to Z, lowercase, A to Z uppercase, 0 to 9, and the underscore. And that is the same as /W. /W is a word character or a valid C identifier character. So it will match one character in that set. Blank, space, tab, carriage return, new line, form feed is roughly the same as \S, which is a space or a white space. You can put a caret in the front, in which case it negates the contents of what's in the square bracket. And this would be a not a digit. And you can use a \D to indicate not a digit, and \W to indicate not a word character, and \S to indicate not a space. And so there's a couple other rules that we need to cover to make this work. But let's take a look at this example. We want to match a phone number, right? Phone number looks like that. So how do we describe a phone number with a regular expression? So let's look at the pieces. So a plus, so inside a regular expression, any of the shifted number characters, all those special symbols, they most of the time have special meaning, and maybe you remember all of them and maybe you don't. But if you put a / in front of it, then it's a literal character, okay? Most things in regular expression, if you take any character like A through Z, 0 to 9, all these normal characters, they match themselves, right? But if you put a / in front of them, then they have some special rule. So Then we have okay, so backslash plus D question mark. So that is an optional country code, right? This is saying, and let me explain how this works. So this is a plus, this is a digit. Now I have a parentheses, which is called a grouping, and we'll talk about that more later. A question mark. Question mark means 0 or 1 of the thing before. So what this is saying is maybe there's a country code. Make sense? Are you with me? All right, maybe there's a country code. The next thing I'm going to do is going to match a literal parentheses, and then I have a grouping. And inside that grouping, I have 3 backslash Ds in a row. And then I have a close grouping and a close parenthesis, literal close parentheses. Then I have a grouping, 3 more digits, a close parentheses, a minus sign, which matches itself, and then 4 digits. Okay. So I can match a phone number with this pattern. All right. Now, okay, scanner. So what I'm going to do here, I'm going to read input from a scanner, and that scanner is initialized here, and the input for the scanner is constructed there. All right, so inside I'm going to use my scanner to parse this little mathematical expression. And the way that's going to work, I'm going to have this pattern here, and parts of it will make sense. So we have a grouping, which is defined by the parentheses, and there's a special thing here which allows the grouping to have a name. We'll get back to that. We have a minus sign, and minus sign matches itself, right? We said that before. Minus sign matches itself, and I have a question mark after it. So maybe there's a minus sign, is what this is saying. Maybe there's a minus sign. Then there's a backslash D, then there's a plus. Plus means 1 or more of the preceding thing. By the way, I'm saying all these rules like rapid fire, but up at the top, I have some notations, right? If you're following along with your computers open, you can take a look at this and you can refer back to it. Also, if you go here and you go to the Vogela tutorial, there's a big table in here of regular expressions and how they work and all the different symbols that are in them, which I encourage you to look through. Okay. Let's go back to where we were. All right. So I'd found maybe a minus sign followed by a digit, followed by 1 or more digits, right? So maybe a minus sign followed by 1 or more digits. That's an integer, right? So this whole expression from minus question mark backslash D plus is an integer. But somebody needs to ask me a question. Yes, Drew.
I don't understand the double backslash.
Ah, that's the question I wanted. Excellent. Why is there a double backslash? I've been telling you backslash D, and then I went and wrote double backslash. Am I just messing with your heads? A little bit. All right. So the idea is there's 2 different things, and that is the string as it's represented in memory, right? And the string as it's represented in a Java program. Now, Java wants to interpret the backslash, right? When I write a string literal, it wants to interpret the backslash because it knows that backslash n is a new line, backslash t is a tab, and so on. And it's doing all that for me. But it doesn't know what backslash d is as far as the string, as far as the compiler is concerned. Backslash d isn't legal to put in a string. And so what happens is Java would refuse to take it. But Java will take backslash as a way to represent the backslash in the string. So if I want a backslash D to appear in memory in my program, I have to put backslash D when I'm writing the expression in double quotes. Does that make sense? Now, this is fun. Suppose I want to match a backslash, right? I want to match a backslash, a literal backslash. So both Java, the Java compiler, and the regular expression library are going to be interpreting that backslash. So I have to put backslash backslash so that the string has one backslash. But the regular expression engine needs to have backslash backslash to match a backslash. So I have to write backslash 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 to match a backslash. Hopefully you won't do that too often, but that's what you have to do. Now, other languages have special support for regular expressions and putting them in strings, so you don't have to twist your brain around these extra backslashes, but Java does not. All right, so this is, so minus question mark, and I will sometimes use backslash D and backslash D interchangeably. And I want you to just understand up front that if I'm putting the two backslashes, that's because I'm taking account of the Java compiler interpreting. All right, but if you get confused, just ask. All right, minus question backslash D plus, that's an integer. We got that much. Whole bunch of coding, whole bunch of talking just to get that through. Okay, backslash S is a space. Backslash S is a space. So that's space, tab, new line, carriage return, all those things. There's probably like 20 different weird things. There's, page feed and whatever. Anyway, so I'm going to say a space, but there's 0 or more of them. That's what a star means. Star means 0 or more. So backslash S star is any number of spaces, or maybe none at all. All right, and then I'm going to have plus minus inside a square brackets. So that's going to match either a plus or a minus. Now, again, like there's always a weird exception going on, right? So I told you 0 minus 9 was the range 0 to 9. So if I want the minus to be literal, I need to put it at the end or the beginning. Okay, so this will match a plus or a minus. This is another arbitrary amount of spaces. This is a digit this is an integer that doesn't have the option of being negative, can only be a positive integer. This is 0 or more spaces. An equal sign matches itself, 0 or more spaces, and then another integer inside a grouping. Okay, so now if you've been following along and your brains are working at top speed, you have digested 2 of these regular expressions. This one, which matches a phone number, and this one, which matches a mathematical expression. Yes, Logan.
So for in the brackets, like with the plus minus,
yes.
could you also do like the backslashes before the minus?
You could do it, yes, you could put it black. So the question is, can I put a backslash before the minus if I want it to be literal? And yes, I can. Okay, so now what I'm going to do is I'm going to parse this string with the scanner. I'm going to say, well, has next line. Well, it only has one line, right? And that's this. So I'm going to parse that line. I'm going to say it has the line, so I'll get into here. And it'll say s.find inline pattern, right? And I'm passing this string in here as a pattern. And if this does not return null, that means I found the match. And I can print that out gloriously. Match found. And now I'm going to get the match result. Okay. And the match result comes back with s.match. And what's a match result? Match result is a special object which allows you to access all the different groups. So in this case, the first group I want to access is the one I named first. So that's this. So this question mark angle bracket first thing that names the group. And that means that when I have a match result, I can find whatever piece of the pattern matched that through that name. Alternatively, I can get the name, I can get the groups by their number. Each of them has a number, and the number of the group corresponds to the position of its left parentheses. So this is group 1 because its parenthesis starts here. The next group is this one. So this is group 2. And the next open parentheses is here. So that's group 3. And so what I've done, right, is I've taken this mathematical equation that I've written and I've parsed it. And just by saying this pattern here, I say I have a mathematical equation, and then I can pull out the pieces one by one and do things with them. Now, if you think about how short this little piece of code is here, and this little piece of code is here, right? You think about how short those pieces of code are and how I can pull out all those different pieces and find everything all at once. It's a huge simplification in your code. And once you get familiar with the elements of a regular expression, you can easily pull out all kinds of complicated things from pieces of text without thinking too hard. But understanding regular expressions does take a bit of work, but it's worth it. As I say, I find almost every day a use for a regular expression. So I encourage you to dig in on this one. And again, this transcends Java. Every language has a regular expression library, and it all works. There are some variations, but they all work along this line. So this is knowledge that not only is useful in this course, but will be useful in all your other courses and in your life to come. Okay. So any questions about any of that? Yes, Drew.
Can you offer the phone number pattern?
Yeah.
What is the country?
Okay, so what the country code is doing. So I was asked about the country code in the phone number example. In the country code, what I have is a literal plus sign followed by a single digit. Now, maybe country codes can have 2 digits. I'm just thinking about the US, which is 1, of course. But the idea is I have plus and a single digit, and this whole thing is in a group with a question mark after it. So it means that there could be a country code or not. But if there is, we're gonna catch it. So imagine writing code to parse a phone number and looking for all these different things. Imagine how many lines of code that would take you if you didn't have a regular expression capability. All right. I still have 3 minutes. Don't pack up. All right. So now I'm going to have, I can use a scanner. Now, remember, we've learned something about scanner today, right? We always, probably in 1350, you just instantiated it with an empty constructor, but you can instantiate it with a string, in which case it will parse that string, or you can instantiate it with a file reader or file object, in which case it will read that file. And what I'm going to do is I'm going to look for this pattern using the scanner. So what's the pattern? It's white space, word character, 0 or more white spaces, 1 or more words, 0 or more white spaces, 1 or more word characters, 1 or more white spaces, this time not 0 or more, 1 or more, and then 1 or more digits, followed by dot star. Now dot matches any character except a new line. And star, of course, matches 0 or more of something. So dot star is kind of like anything. Anything to the end of line. All right. So I'm going to say sr.find in pattern, find in line pattern. And if the pattern exists, I'm going to get the match result. And I'm going to get first, last, and age. Remember that file that we created with first, last name, and age in it? I'm now parsing it using a regular expression instead of, the scanner's next methods. Now, for something as simple as that file, regular expression is probably more work than just what the scanner provides out of the box. But it shows how you can use these tools together, how you can read a file and parse that file using a regular expression. All right, and I guess that's as much as I will talk at you right now. If there's any final questions before you go. All right. See you next time.